Perfect. Thank you. Hello, everybody. Welcome back to Comp 2450, Software Development 1. I hope that you are all doing great today. I've got goosebumps here because you all just silenced yourselves at the correct time. Thank you for that. I hope you're all doing great. Today, what we're going to do is kind of continue along with what we were doing on Monday's class. So what I want to accomplish today is I want you to be able to sketch the flow of interaction in an interactive system before implementing it. And so what I want to be able to do as part of this today is I want to be able to identify the tasks that are part of interactions with software, given a description of the software. So in general, when we're doing this whole sketching flow of interaction thing in this course at the 2000 level, I'm not asking you to start from nothing here. I'm giving you a system. In the case of class today, we're going to be working from an existing game. In the case of your projects, I'm just going to tell you what the tasks are that I want your person that's using your software to be able to accomplish. As you get higher in university and as you get out into the real world, you're going to have to start doing this from scratch, but we want to just practice, like, given a system, let's reverse engineer it and start building this thing up. So part of this is going to be that I want you to be able to identify like subtasks, so the smaller things that are necessary to accomplish a task given this big description of a task, but I want you to be able to do that given some detailed description of the software that we're working with. And then what I want you to be able to do is informally, I want you to be able to sketch this flow of interaction using tasks, subtasks, inputs, processing, and outputs. We're going to use Mermaid for this. Mermaid has a flowchart type of diagram mechanism that I'll expect you to take a look at and use. But for class today, I just want to focus on the exercise of drawing all this stuff out. So to start, what I want to do is give us a quick review of what we had last class. So the idea here with flows of interaction is once we've got an idea of what this system is, this thing that's been provided to us, either the whole system or some small action that I want to do in this thing, I effectively want to be able to describe how somebody is going to interact with our system. And that means that what I want to be able to describe to in my diagram is I want to be able to show, like, these are the small parts of things that they're going to need to do to accomplish this task. These are the inputs that they're going to have to give to me to be able to accomplish that task. I want to be able to identify at an extremely high level the processing that the system does. This is a non-technical exercise. I'm not looking to give names of methods or variables. I'm not even really looking to define in pseudocode what's happening here. I'm writing two words to describe the kind of processing that's going to happen in this thing. And then I want to be able to describe the outputs that are produced by processing in the system. So my processing task starts to happen. My computer takes over. The system is doing something. What output does it provide? And how does it go between the different tasks and subtasks that we have in the system? So to start, I want to do a really quick review quiz. I'll hold this up for about 10 seconds. I saw when I started Mentimeter that there were already people joined, which is awesome. But I'll hold this up for about 5 seconds, and then I'll switch over to Mentimeter. Okay, awesome. I'm going to switch to Mentimeter. Just a small note, somebody in class mentioned that the audio from my mic was really, really quiet, and then it was really, really loud when the YouTube video came on that I played for you. I tried to adjust the slider for volume on the video. I don't ever listen to these, so I have no idea what volume levels are at. If you go back and you find that I'm just like completely blown out the whole time, please let me know so I can move the slider back down again. Okay. Okay, awesome. Yes. So the main thing that we're really trying to accomplish here is to figure out effectively how somebody is going to use the software. That's the high-level goal that we have for this thing. The processing steps, like I said, we're going to describe at an extremely high level what the system is going to do to accomplish this task, to accomplish the subtask given the inputs that we have from this thing. But I'm not really providing any detail here. I'm not going to say how, for example, a login system would validate user passwords. I don't care how it validates user passwords. That's not what we're trying to accomplish at this point. We're just trying to validate user passwords, period, end, full stop. That's the description of the processing that we're looking at here. We are going to figure out what kinds of inputs that somebody gives to us. This is a valid thing that we're doing, but ultimately it's to this end, figuring out how someone is accomplishing some task in the system that we've got here. Here's our next question. Okay, awesome. Yes, this is a negation question. I don't really usually like these kinds of questions for like tests or quizzes because, I don't know, whenever I answered those questions as a student, I always felt like someone's trying to trick me and I can't do like the negation of stuff in my head. But I'm delighted that many of you are picking the right answer here. We're not including method names. Probably, when we do implement this sketch, that diamond shape is going to turn into a method, probably. I'm not going to say that's a hard rule, but probably. It's probably also going to take the inputs that we're identifying as parameters, probably, but that's not what we're trying to accomplish here. We want to keep things at a pretty high level and effectively non-technical here. So I don't want to have method and parameter names in the sketch that we've got here. Araragi Koyomi. Okay, congratulations to that person. There's still 2 more questions though, so things could totally get shaken up here. Okay. Okay, awesome. Yes. So a majority of people are picking 0 to infinity. This is what we're looking at here. There can basically be more than one output produced by processing. Technically, I suppose I should have written this as 1 is less than or equal to n to make it clear that there's always going to be at least one output produced by this thing. But there's going to be at least one output produced by this thing, and there could be as many as an infinite number. We're not going to draw diagrams that have an infinite number of lines on them, so we're not going to worry too much about that. It's usually going to be like 3 to 4 different kinds of outputs that are going to be produced by one of these processing steps. Here's our last question. Awesome. Yeah. So we're using that diamond shape to indicate that this is something that our system is going to be doing for us, that we're going to be doing in our machine as processing. Okay, this is a big shakeup because I think many of the people that were there are no longer. Congratulations, Genius, for being on the top of the leaderboard this time. I'm going to come back to this Mentimeter, so if you can keep it open, if you want to keep it open, please leave it open. But we're not going to have quiz questions anymore. I'm gonna be looking for input from you for this. All right, so let's pop back to my slides here. And what I want to accomplish here is what I mentioned last time. I want to go through the process of drawing one of these tasks. And I want to go through and identify the subtasks, the inputs, the processing steps, and the outputs produced by these processing steps, and kind of how we're working through this whole thing. The example task that I am thinking about here is a battle in Pokemon. This is the task, a battle. And to do this, what I want to do is I'm going to pop over here and I'm going to bring up my tablet because I'm going to want to be able to draw this for you. I invite you to draw along with me. The other thing that I'm going to do is I'm going to have this emulator open. With this, I promise to you that this is a completely legal ROM. I actually, you're all chuckling here. I do actually have the hardware to plug a Game Boy cartridge into a USB port on my computer and dump a ROM from the cartridge. I'm dumping the ROMs and the save states of these games because I play them with my children, and as they get older, I want to embarrass them with the names that they've selected for the Pokemon that they have. Don't tell them that right now, though. So the first thing that I want to do here is I'm going to put this just over to the side so that we can see this. I'm going to be able to draw on my tablet while this is up. And I have already pre-muted this, so I'm hoping that it's not like destroying the audio in the stream right now. I'm going to take Pikachu here, and we're going to get into a battle in some tall grass. So the big task that we've got here is that I want to be able to describe the battle. This is the task that we have in this system. So as I mentioned last time, the symbol that we're kind of using for this is this rounded rectangle shape. I'm going to draw this rounded rectangle here, and I'm going to leave the sides off so that if I need more space, I can keep going with this. But I'm going to give this big task that we've got here a name, which is battle. The first thing that we want to have in our flow of interaction diagram for the task that is a battle is I want to have the starting subtask here. The starting subtask, remember or recall, or I'll tell you right now, the symbol that I want to use for that is this double rectangle shape. And I'm just drawing this with kind of rectangles on the end here. And the thing that I want to put in here is effectively a label of what the person using my software is actually going to see at this point. This is going to be a really short description, a really short label of what they're seeing. And so what I'm going to say here is that what we're looking at right now is the battle screen. I'm going to make this box a little bigger so that I can write a little bit bigger. So this is the battle screen. And this is our starting point. I'm going to annotate this. This is our starting subtask. This is our starting subtask. From this subtask, there are inputs that I am being expected to provide as the person that's using this software. The inputs that I'm being expected to provide here are a choice of the different actions that I want to take from this spot. From this spot, from this starting task, from the battle screen here, there are 4 different options that I have to provide as inputs. There's fight, there's item, there's Pokemon, and there's run. Those are the 4 different actions that I can take. These are the inputs that I can provide to the system right now. When I'm drawing this out, because there are exactly 4 things, the 4 possible options of inputs that I can provide here, I'm just going to draw these as separate lines. Sometimes when I can make a choice of an arbitrary number of things, I'm just going to put 1 line and I'm going to say the choice of that thing. But in this case, I'm going to draw 4 different lines because these are the only 4 things that I can choose from. So I'm going to say here that I've got 1 line that's an input, and I'm going to label it fight. I've got another line that's an input here. I'm going to label that item. I've got another line that's an input here. I'm going to label that PKMN for Pokemon. And then one last thing that I'm going to label here, which is the run input. So there are 4 different inputs that I can provide here. Again, my choice to give these different lines is because there are exactly 4 things that I can do here. We're going to follow through the fight sub-item here. I'm going to leave the rest of these blank for now. We will fill them in together, or I leave you to fill them in on your own if you want to do this as kind of practice to build up this flow of interaction on your own time. We're going to go through with this fight system. And with the fight system, what we're effectively doing here is we're going to move to another subtask. So I'm going to hit A on my Game Boy here. And now we are presented with another subtask. The subtask that we're being presented here with right now is not the starting subtask anymore. So I'm just drawing this as a rectangle. And the subtask that we're being presented with here is move selection. I have to choose which move I want to use to attack this Pokemon right now. There are exactly 4 options here, but, and I'm going to tell you a little bit about Pokemon here, there are hundreds of different possible moves. There are way too many different moves that different Pokemon can have that I could really realistically list as outputs or inputs from this subtask. And so the way that I'm going to work with this one, unlike the previous screen that we were looking at, where there's exactly 4 things and there are only ever going to be 4 different inputs that I could choose from, there are many different kinds of inputs that I can choose from here. And so what I'm going to say here is that I'm going to provide an input from the move selection screen that is the selected move. So it's just one line, but there's an arbitrary number of options that could potentially go in here. I don't want to draw all those lines, so I'm just going to collapse this into one specific input. Once I select a move, let's let chat play Pokemon right now. What move should I pick? Growl. Okay, Growl is the least useful move, but thank you. I'm going to use Growl, and I pressed A by selecting that. And now a bunch of stuff has happened. And so what we've done by providing that input is we're now moving into a situation where the system is doing stuff for us. So here, I'm going to draw a diamond. This is a processing step. So our rectangles are where I am being asked to provide input as the person using the system. I'm being asked to interact with this thing. I have now provided some input here, and now the system does something. I'm going to label this as do attack. Again, high-level description. We saw that a bunch of stuff happened here. I don't care what that is right now. That's not what I'm trying to accomplish. I just want to know that the computer or the system is doing this task for me. And that, at an extremely high level, is what the system is doing for me. This may turn into a method later, maybe. The inputs that we've selected may turn into arguments or parameters to that method later, maybe. But for now, we're just saying the system is taking over and stuff is happening. Something is happening with this system. I'm going to say that the result of do attack here, the output of do attack, in this case, is going to be dashed line. So output is, remember, dashed line here. The output to this is that the attack has happened. And when I press A, we're playing the computer, but what I'm going to say here is that we've effectively switched players. The outcome of this was that our enemy didn't faint. We did not defeat our enemy. That's the outcome of this. Our enemy did not faint. And so now the system has to do another thing. The other thing that our system is going to do here is that we switched players. So let me take us through that again. Fight, growl. I selected this move. Some action has happened here in the system. The attack has finished. Now we've switched players because our enemy has not fainted. And what's really happening is, if I imagine that there's actually a person being the Rattata character here, the outcome of this is that I'm actually going all the way back up to the top here for player 2 in my system, back to this battle screen. Players switch players, and the outcome of this is that I'm actually going to write the words switched players to describe the output of this. So current player is no longer player 1, it is now player 2 in this system. And if there were another person pretending to be Rattata here, they would have to go through this whole flow again. They would go through that whole flow, then we would switch users. Then I would go through that flow, then we would switch users. Yeah?
For example, the NPC, the enemy we're fighting, they could also run.
Yes. I believe wild Pokemon can run. I believe. I don't think trainers can run away from you. And I don't think you can run from trainers either. But I'm going to say that in this case, you can run away cowardly, I guess, if you're, yeah. But that's a good question. Thank you. Yeah, yes. If we have a choice, that's a great question. If I have a choice, if I've got 2 players in my system and each player has different options, then I have 2 different flows of interaction to represent those things.
So we could not use the switch players processing diamonds?
If the other player has to do something different, then what I would say is that, yes, you could have a switch players processing diamond, but then that leads to a different flow of interaction. It might be within the same diagram, but it's not going to go back in a loop in the same way that I've done it here. Yeah. Yeah. Then we would go back up again. And so it would just be a longer chain of things, and then it would go back up to the top again. Yeah. I want to keep this simple just to make sure that I can fit this onto one screen. Yeah. Okay. So this is one complete cycle through this flow of interaction, but I want to be able to end this flow of interaction. And so I'm going to do what most people probably would do in this circumstance and not use Growl or Tail Whip, but just go straight for the attacks that actually cause damage. And so I'm going to keep doing this. I'm going to keep running through this flow of interaction. I'm going to keep selecting Thundershock. And what I ultimately want to get to is the state where we have finished do attack. Awesome, we got a critical hit. We're going to get to the end of a do attack here, which is that the effects have been applied to this Pokemon. This is the other possible output from this state of do attack. The other possible outcome from this, and I'm going to draw this arrow way over here, is that our enemy fainted. When our enemy faints in this game, enemy Rattata has fainted, we get experience But then it's over. The whole flow of interaction is over at this point. We go back to this overworld. So what I want to have here at the end of this is I've got an end state or an end subtask. This is a double rectangle again, and I'm going to say here battle ended. So we start at the battle screen, we work our way through selecting a move. We have 4 options to start on that battle screen. There's exactly 4 options, so we're listing each of those 4 things as different paths through this. If we choose fight, we're then moved to another place where we're asked to select the move that we want. We provide that move as input to the system's processing task of doing the attack itself. The output or the outcomes from the attack is that our enemy faints or does not faint. If our enemy faints, it's over. If our enemy does not faint, we switch players and go back to the start of this entire flow of interaction again. This flow of interaction that we have on our screen right now, you could reasonably re-implement this as a text-based interaction. I haven't said anything about how we select the move. I haven't said anything about how we select fight, item, Pokemon, or run here. I've just described that these are the inputs that are expected. You could make this a web browser-based game where you're just like clicking buttons and typing stuff in if you wanted. I have not described anything about how this is presented to the person using my system. These are just the different tasks that are going to happen here. Okay, the other thing that I want to take a look at here is I want to add to this flow of interaction, and I want to add to this flow of interaction in a way that is going to show kind of an error state. So like I've given input that is not a valid selection. Yeah. Yeah. So this could be a processing part here. So like do battle end stuff. But there's only going to be one line here. That just goes directly to the end here. And there's only one line. And so I just tried to simplify that without having that step. Yeah. Possibly, yes. I think it probably makes more sense to explicitly state it here. And so I'm actually going to label this arrow here, enemy fainted, do battle end, collect experience as the output, or experience collected. Yeah.
So here we're drawing the flow of interaction, but we already have the game.
Yes.
Like in our project, we don't know the final result, how it would look like. So how are we expected to draw that?
So starting in phase 2, you're going to be given descriptions of tasks that we want to be able to accomplish in your game. And from those tasks, you're going to be drawing these flows of interaction for your own system before you start implementing it. Yeah.
So the starting and ending tasks, they usually just don't do anything. They usually say this is the start or and the other input, and the end says this is the end. Because I assume we could have the ending task being the gathering of XP after the battle finished, but here we did it as a processing task, and then the end task just says like this ended.
Well, so I want to explicitly model the collection of experience as something that the system is doing, because I, as a user, am not providing any input about what the amount of experience that's collected here is. It's something that my system has to process for me. So I wanted to try and separate, I do want to separate those things, and that's what I've done here, is separate them into 2 different items where we've got the processing task of collecting experience. The battle ended here is effectively return back to the overworld so that we can start moving around on our map again. That's really what we want to happen here. Yeah. That is an excellent question. I can only give you advice, and I can only give you advice that maybe even doesn't work for me. remind yourself of the design philosophies that we introduced very early in this course. Keep it sweet and simple, and you ain't going to need it. One of the advantages that we've got with an existing flow of interaction, like what we're doing here, we're reverse engineering something. So in this specific case, when I get to the battle screen, you're going to have to forgive me about Pokemon here because I've only ever played these games. I've seen my kids playing Pokemon Sword and Shield, and I know that there are way more options here. There are way more options at this point. And so if you're starting to think, how do I get to that version of Pokemon as opposed to what I'm looking at right now, the advice I have for you right now is remind yourself of what you are looking at right now. Don't worry about what you might need to have later. Focus on what you need right now in this specific moment. Okay? Okay, so I want to run away cowardly. I got away safely. And what I want to be able to do is I'm going to do something, and I'm going to, even before I start this, I am really like, I want to make a 1,000 million, like infinity% clear that what I'm about to do is not in scope for this course, okay? You can shut your brains off if you don't want to. You will see stuff like this in an operating systems course at the 3,000 or 4,000 level in this department. But I have to cheat at Pokemon to accomplish the thing that I want to show you. And so the way that I'm going to cheat at Pokemon to accomplish the thing I want to show you is I'm going to start manipulating memory in the emulator so that I can basically change it so that I don't have any of a certain move left. So I'm cheating to lose here, to be clear, but I'm going to be manipulating memory to do this. And so this is a nice website. I've linked to this in the course webpage. Somebody else has done all this work in advance. What I want to do is I want to find information about the player. And this is the Pokemon that they're currently carrying right now. What's listed here are memory addresses. So are you all taking Comp 2280 right now? Some of you? No, okay, some of you maybe, but not yet. You'll take that next term, yes? Introduction to Computer Systems, yeah. So you may start to see some of this stuff in that course, but it's when you get to an operating systems course or another 3,000 or 4,000 level systems course that you'd see this. So what I want to do is I want to change one of my moves here so that I have no PowerPoints left. I can't do this move because I don't have any of this left. This is surprisingly difficult or impossible to do very early game without cheating like this because you faint and then you go back to mom's house and then you're fully restored again. So you can't just use growl and growl and growl and growl and then run away. You have to actually do something like this. I'm using Pokemon Yellow, so the addresses are slightly different than what's listed here because this is for Pokemon Red and Blue. But again, please shut your brains off if you don't want to follow along with what I'm doing here. I just kind of want to show you that this can happen. So the address that I want to change the address. I want to change the value for the third item that we have in our move list. So I'm going to go to D189. D189 here is the total number of PowerPoints that I have for the last move in my system. This is very small, but what I want to point out here is that this is the number 30 right now. This says this is how many times I can do that specific move. I'm going to change this value to 0, and then I'm going to go back to my game, and what I'm going to do is start moving around here. And I'm going to start this interaction again. So I'm going to bring back my diagram. I'm going to bring back the emulator window here. And what I want to be able to do is from the move selection screen. So right now, we are starting here. We're starting at this subtask, move selection. And I'm going to go to tail whip here. And now I have none left. I can't do this. I can choose this thing. This is an input that I can provide in this system, but there's nothing left. I can't do this because I don't have any instances of this move to be able to do anymore. And so from the do attack system operation, I'm going to hit A here. Hitting A is going to move me from move selection to input provided of selected move, and we've entered the do attack system operation here. From do attack, we have two options right now, which are the enemy has fainted or the enemy did not faint. But now we have one additional thing, which is that there's no PP left for the move that you selected. This, I'm going to represent this here as this is going to be an output from this state, and we're going to say, or from this system processing part, I'm going to say no PP for move. And we're going to effectively go back to this move selection screen. So within this flow of interaction, we got to move selection. I picked something, but it wasn't really something that I should be able to pick. I moved into this do attack system processing part, and the output of this is that there is no PP left for that move. And I go back to move selection. What's happening with this output or outcome here is that this actually shows up as a message on my screen. There's no PP left for move. I hit A and I go back to this move selection thing. In the same way that these diamonds are going to probably turn into methods, and the inputs we're providing are probably going to turn into parameters that we're putting to those methods, some of these output messages are going to probably show up as messages on your screen, something that you'll actually print to say this is what has happened as output from this processing step. All right. I'm going to run away. And I feel like we've cheated ourselves by cheating to lose here. So I'm going to change one other address here, and that is D18B. This represents the level of the Pokemon that we're looking at right now. So we're level 6. I'm going to change this to 64. And then I'm going to take a look at my Pokemon. And now Pikachu's level 100. Awesome. We won the game. Yes. Yeah.
When we are, I guess, actually implementing this, should we essentially have all the outputs in a class of their own, not the inputs in a class of their own, separate from?
So that's a good question. Basically, how do I take this and turn it into code? Yeah. We'll talk about that next week. But high level, this is not a hard rule. High level, the subtask, the task that I'm drawing here in the big rounded rectangle, that's probably a class. The tasks, the squares and rectangles that I'm drawing here, these are probably methods. These are probably methods. They may even be classes because they're going to start to do interaction of input and output. The diamond shapes are probably going to be methods in the class. This may turn into multiple classes. This may turn into one class with a bunch of different methods in it, but we'll think about that next week. Okay. So if that's an acceptable answer for now, I'm going to say we'll keep moving with what we're doing. But yeah. Any other questions about this so far? Yeah.
Single input for each processing. If we want multiple inputs, do we have a single subtask that gathers those all and we have multiple lines into the processing, or we have to separate subtasks?
That's a great question. So the question is, if I have multiple things that I'm selecting as input, should I have one line or multiple lines? I'm going to mark up my diagram here with just a different color to indicate like alternatives for you here. So here we have exactly one thing that we're choosing, but if there were more than one thing, if more than one, then just list them. So if I have to choose the level, and I'm going to modify gameplay here for a second, and I have to choose what level I want to cast that spell at, then I would say I need to choose the attack and the level that I want to cast that at. Yeah. And I would just list those two things here on that one single line as opposed to having multiple lines of input. Yeah.
So whenever you want to create variables, is it better to make an entire new task and subtask for them, or is it better to just try to implement them in a given selection? For example, if I were to create, let's say, we're just talking about Pokemon here. Let's say we're talking about some kind of data structured implementation.
where it would make sense that even though they're same data types, they might perform different functions? Is it always better to always implement more subtasks and make it more complicated, or just create a new one if it's too complicated?
I guess I maybe have to remind you that we're working from an existing system here. And so when we're working from existing systems, there's always going to be these logical breaking points that we can make observations about. I may be misunderstanding what you're asking, but yeah, I think I'm misunderstanding what you're asking. Okay.
That should be, should our flow be, is it always better to have one flow for all of our operations, or we implement different ones for all scenarios?
So generally, we're going to have one flow per task. And the task that we have, at least with Pokemon here, is the example that we're working through right now is the battle task. This is the task that we're working with. There are many different subflows within that. And we've got one of those flows that we've taken through completely by following the fight option as an input here. This to me is a task. When I'm describing things to you in your project phase 2 description, I'm going to give you tasks. And that's approximately the breakdown that I'd expect you to put those things into. We could have like arbitrarily nested tasks within tasks within tasks. And so I could do things like put another rounded rectangle around the runaway thing. I could put another rounded rectangle around Pokemon. I could put another rounded rectangle around the item subflow. I could do that if I wanted to, if you wanted to have this arbitrary depth. But in terms of what we're thinking about, we're going to have one task, and then there's going to be a flow within that that's containing all the subtasks for that thing. Did I better answer your question this time? Okay, okay. Sure.
For example, let's say that after we've done attack, we want to ask them, hey, do you want to catch this Pokemon for the low health is low enough? So would you say that the battle here would encompass the catching Pokemon part as well? Or would you be a new task for that?
The battle here, I guess, would encompass the capturing of Pokemon, because that would then come off of the item flow. So this is now us talking about Pokemon more than, but to capture a Pokemon, I need to choose the item operation here. I don't have any items here to choose from, but I would have Pokeballs here. And then that would be a system processing step of decide whether or not you've captured this Pokemon. The output is either you caught it, then you go to the battle ended screen, or you haven't caught it and you go back to the battle starts. Yeah, yeah. So that to me would still be part of this task, because it's contained within the set of things that we're accomplishing from the initial menu that we're seeing here. Yeah. Okay. All right, awesome. Okay. So one thing that I would like to do now is I would like us to start thinking about how we can accomplish something like this ourselves. And so the question that I want to start asking you is, and I'm going to have to ask you to use your imagination, because I failed to actually buy any items to do this with, but I'm going to ask you to use your imagination. Yeah.
And he said, like, if we fail to get Pokemon with the Pokeball, it would then attack you.
Yes.
So then we would like go into the do attack function from the items.
Then we would go to the switch players action, I think, as opposed to going directly back to the battle screen, because we don't get to attack it again after we use a Pokeball. It then has a turn to attack us back.
We can like go from like different spots like that.
Yes, there's nothing stopping us from going to one task that's being one processing step that's being used somewhere else in the system. Yeah. Okay. All right. So I'm going to pop back to my slides for just 1 second here. We've got about 5 minutes left in class. And so the thing that I want to start working together on is the item subtask here. This is the same Mentimeter that you were looking at before. So if you are still connected, awesome. If you've become disconnected, then I'll put this up here for a couple of seconds. And then what I want to do is ask you questions about the state that we're going to go in from this item menu. So I'm going to switch back to the Mentimeter here. I'm going to move to the next slide, and I'm going to ask initially, once I make this selection of item, what are the kinds of things that I can do with this item subtask? So catch Pokemon, use item, choose item, selected item, Wakanda. This is a completely different universe, but okay. Apply item, heal, restore health, use evolution stone, select item, select specific item, heal Pokemon, use potion. Whatever user needs to provide, yes, okay. Apply item, use that gear in activity, select item, heal condition, select item, die, okay. I don't believe that there is an option to die at all in this game, but okay. So the one thing that I see frequently here is the things we can select. So catch Pokemon, use a Pokeball, use a potion, restore health, heal, use evolution stone. Those are valid things, but those are specific instances. And in the same way that attacking has an arbitrary number of options that we could potentially select here, there's an arbitrary number of items that we can choose from in this item subtask screen, an arbitrary number of different items. So the thing that we're really going to pick on here, and I'm going to choose this one just because it happens to be here right now, the thing that we're getting as an input from the item subtask is the item that's been selected. So I'm going to go back to my drawing, and I'm going to add that. I've got an item here, and I'm going to be presented with a subtask. I'm going to make sure I'm using the right color for this. Item selection. And what I'm getting as an output from item selection here is the selected item. So the same thing is happening here between move selection and item selection. Battle screen, again, we're listing all 4 possible outputs because there are only 4 possible outputs. There will never be anything else in this system. But with move selection and with item selection, there's an arbitrary number of different options that we could choose here. And the thing that we have selected is the input that's being provided to the next step. Once we've selected an item, what I'm going to say about this is that we're going to go into a system processing step. I'm going to write the words apply item or use. I'm actually going to write the word use item here. And I'm going to switch back to Mentimeter. And I'm going to ask the same question here. What kind of outputs can be produced by this use item processing step? Once I do this thing, what might my system be doing as response to making that selection? Perform the Z move, Z or Z move? No, we can't do that in this version of Pokemon. The item is used successfully, increase, decrease health, the health is restored, item was used, apply item effects, heal Pokemon. Okay, yes. So I'm going to pick apply item effects here, and I'll go back to the other responses, but I believe that this is one possible output that can be provided by this system. So I'm going to go here, I'm going to say use item, I'm going to start drawing a dashed arrow here, apply effects. Or the effect has been applied. And then I don't actually remember where this goes, but I'm going to say we go back to the battle selection screen. It's the same player that gets to go again. Is that true? No, it's the next player. So we're going to move our arrow here, our dashed arrow, all the way down to the switch players. Thank you for shaking your head at me when I said that. Awesome. Okay, so we're going back down to the switch players. We switch players, and we start this flow all over again. I'm going to go back to Mentimeter because I did see this show up here. Item was used successfully. That is a valid thing that we have here. Out of item, yes. And I'm going to say, muscle man, okay, none of item remaining. The other thing that I'm going to say as a possible output here is that you can't use this thing. You can't, for example, choose your bike in this battle. I can't choose my bike as an item, or I can't choose the map as an item. So I'm going to pop back here. I'm going to have this self loop here that's basically can't use. I'm going to have this pointing back, sorry, to the selected item. Can't use. I'll clean this up and I'll post this up on the course webpage for you. But at this point, what you should be able to do is identify tasks and subtasks that are part of interactions with software, given a detailed description of that software. And you should now informally be able to sketch the flow of interaction for a system that includes things like tasks, subtasks, inputs, processing, and outputs. That's it for today. Thank you all for sticking around for a couple extra minutes, and I'll see you on Friday. Bye, everyone.